Hi, tonight I want to record a video to deal with what I did wrong while choosing the pins to connect the CAN transceivers to the microcontrollers because, well, it didn't work at first and I had to modify my wiring to fix this. So I'll show you what was wrong. So let me remind you what this video is about. This video is about a project that I recorded a video just before. It is my CAN bus to Wi-Fi project. So I'll let you check out my previous video if you want to know what this project is. So after doing a small program, I flashed the microcontroller I wanted to make a program for, and it didn't boot. It was basically waiting for something. I was trying to figure out what the hell is this, and basically the mistake was, as you can see, when I started monitoring the communication between the computer and the microcontroller, it displayed waiting for download, and I was like, what the hell is this thing? So what I first did is unplugging the power from the CAN bus transceiver, and yeah, my microcontroller went back to life. So I was like, what is wrong? Do I pull too much power from the 3.3 volt regulator on the microcontroller board? And well, so I figured out what is wrong, and let me show you what I just modified. It's very simple, but you have to check out the documentation in order to figure this out. So what's the plan? On the plan, the difference from the previous cabling plan is that I just swapped the CAN bus transmission pin with the CAN bus receive pin. So the problem is that I was driving IO0 at a low level when the ESP32 was booting up. So, and why is it a problem? So, if I drive IO0 with an output at a low level, what happens is, okay, what does the documentation state? During the chip system reset release, so that happens on power run reset or RTC watchdog reset or brownout reset, the latches of the strapping pins sample the voltage level as strapping bits of 0 or 1 and hold these bits until the chip is powered down or shut down. Well, I don't care about this. The strapping bits configure the device's boot mode, the operating voltage of VDD SDIO, and other initial system settings. After reset release, the strapping pins work as normal function pins. And in the table, you see under booting mode that the GPIO 0 pin, if it's driven to 0, triggers a booting mode of download boot. And that means, if I'm right, that you have to send the firmware directly through the UART port. This is what you may want to do when you do some experiments without having to reflash the SPI flash. The SPI flash is built in to the ESP32 Room 32 chip, and this package is covered with a shield. That's why you don't see it, but there's underneath that SPI memory. So basically, the ESP32 was waiting for a download to be received on the UART port, and nothing was happening because I was sending nothing. Yeah, so this is not what I wanted. So what I did is I swapped the CAN bus lines, which are connected on GPIO0 and GPIO2, in order to have an input connected on IO0. So by doing that, I don't drive IO0 during boot up, and in this case it will normally boot on the SPI flash. So these are the pins I swapped in order to have a proper boot up. But unfortunately, I had a surprise. I don't have the wiring diagram of the microcontroller board, and it happens that on that board there is the blue LED connected to IO2. So whenever the CAN bus transceiver is connected, there is a blue light that is on. I think it should blink, well, blinking or just having a lower brightness, because you won't see really the bits reducing the applied power. The mean applied power will drop slightly, and you should see a brightness drop when there is CAN bus data on the bus. I'm showing this because I'll unplug the CAN transceiver wires, and you'll see that the blue LED will just disappear, because it's actually the CAN bus receive wire that is powering IO2. By having a high level on IO2, it powers the blue LED, and I'm not super happy of that, because it will pull some current for no real usage. And as you can see, there is no CAN bus connected, so it will constantly pull that amount of current. I don't know the actual amount, but it's certainly a bad thing for a battery powered device. Yeah, and for the battery of the car. And also, I cannot use the LED for another usage, because it is tied to the CAN bus usage for now. So I'm a little disappointed of my choice. But last time I wanted to figure out how do I turn on that LED. I just couldn't find where it's connected. So unfortunately, I tried, but I failed. So this is the update for tonight, and I wish you all a good day or a good night, and see you in the next video. Bye bye.